forensics is one of the most powerful techniques in modern day incident response and malware analysis. Unlike disk forensics, which looks at what is stored permanently, memory forensics captures what's happening right now inside the system. Running processes, active network, connections, encryption keys, malware in memory, and even hidden rootkits. Why it is important? Because advanced threats often avoid leaking traces on the disk. They operate only in memory, making them invisible to traditional antivirus or file-based investigations. That is why memory forensics comes in. Let us look directly into the live state of the machine. To begin with, first we need to capture the memory safely. Tools like DumpIt or FTK Imager allows us to acquire full memory dump of the target system without altering its consist. This dump is like a snapshot of everything what happening at the exact moment in the time. Once we have the dump, the real investigation begins. Using tools like memprocfs, we can mount the memory dump as a virtual file system. This gives us direct access to the processes, DLLs, handles, registry hives, network connections, and much more, all extracted straight from the memory. By walking through this process step by step, we will see how memory forensics helps uncover hidden malware, detect intrusions, and provide evidence that might otherwise be missed. So let's dive in and start with capturing the memory dump. Welcome back to the channel. Today we are diving deep into one of the most fascinating and critical areas of digital forensics, which is memory forensics. We will explore why RAM analysis is often the make or break moment in any investigation. We will also see how to capture volatile data using tools like DumpIt and FTK Imager. And finally, how to analyze the data using tools like memprocfs. If you have ever wondered how investigations catch fileless malwares, retrieve stolen credentials, or track hidden processes, this video is for you. So stay tuned when we unwind the memory forensics analysis. Let's start with the basics. Memory forensics is the process of capturing and analyzing contents of computer's RAM, random access memory. Unlike your hard drive or SSD, RAM is volatile memory, meaning it only stores data temporarily. Once you shut down or reboot the system, the data is gone forever. So why bother analyzing the RAM? Because RAM contains live data. The programs currently running, open network connections, chat messages, passwords, encryption keys, and sometimes even the files that exist only in memory. Think of RAM like a detective walking into the crime scene. While the crime is still in process, you can see the suspects, the tools they are using, and even catch them in the act. In traditional forensics, we often focus on disk analysis, looking at the files and registry entries. But in modern cyber incidents, especially advanced persistent threats or APTs, attackers often run malicious code entirely in the memory to avoid leaking traces on the disk. For example, fileless malwares that never touches the hard drive, credential harvesting tool like mimikatz that run in the memory and are deleted immediately after use, ransomware loaders that decrypt the main payload into the memory and execute it directly. If you look at the disk, you will miss these things entirely. That is why memory forensics has become a standard part of incident response process. Memory forensics is a part of analyzing computers' volatile memory to uncover the malicious activity and malware such as rootkit, unauthorized access. It provides real-time insight to the active processes and network connection and system states that are not captured in the static disk analysis. It is the crucial step in malware analysis because many malware threats operate only in memory to avoid detection. By examining memory, analysts can identify and understand sophisticated attacks that leave little or no trace on the disk. So, why memory analysis is critical? First, the volatile nature of the RAM that changes every second. In cyber incidents response also, identifying the in-memory malwares and rootkits by the APTs is very essential. So what exactly can we extract from the RAM? We can extract the running processes, all programs currently running and executed, loaded DLLs, shared libraries injected into the process, sometimes malicious. Command line arguments often contain the command attackers executed. Network connections, IP address, ports, and protocols in use. Even the clipboard data could contain sensitive copy-pasted text. Chat logs and messaging data from apps like Teams, Slack, or WhatsApp desktop remain only in the RAM. Passwords and encryption keys, especially for BitLocker or TwoCrypt volumes, are in the RAM itself. Remember, RAM is like a goldmine for volatile evidence, but only if you act fast and efficiently. Now, we will look upon various tools which we can use for acquisition and analysis of the RAM. First step is acquisition of the volatile memory, which is RAM. DumpIt is a free, simple tool that lets you capture the full memory dump with just a few clicks. It is both CLI and GUI based. It generates .raw or .mem image of the volatile memory. Second tool which we will see here in the lab is FTK Imager, a forensic imaging tool by access data that captures RAM as well as the disk, with more options and GUI interface. Finally, we will look upon memprocfs, a unique analysis tools that mount your memory dump as a virtual system so that you can explore processes, DLLs, network data, registry entries if they were on the folders on your computer. You may know that volatility is a most famous tool for memory analysis, but sometimes due to its command line nature and complex programs, it becomes difficult to analyze that. memprocfs, on the other hand, provides GUI options which mounts entire RAM as a Windows subsystem file system, which can be easily loaded and analyzed. Moreover, there are advanced options like running Yara rules in the memory itself in memprocfs, which makes our work more easier. Our first step in the process will be to download DumpIt tool from internet. For that, on your base operating system, go to Google and type DumpIt download. You can download DumpIt from any valid resource whichever is available. You can see here the small description about DumpIt tool, and from here you can choose Windows installation. Save this on the desktop. You can see here it is only 203 KB tool which can be easily downloaded. Our next step in the process will be to take this DumpIt tool into our virtual box where we have done our malware analysis. So for that, go to the virtual box and again make the same shared folder. Select the folder you have to share. I have created a dedicated folder for tools for memprocfs analysis. Come back to the VM and see the networks section. In the network section, you can find our shared folder, and here you can see DumpIt tool. Copy and paste this tool on our desktop. Now, run this DumpIt tool as an administrator. You will be prompted with a UAC, select yes. So this is the window for DumpIt tool. You can see here a small description and copy route about DumpIt tool. Then it is showing the address space size of the ramp and free size. It is also showing us the destination where it will save the image file in raw format and the name of the file. So type yes to give confirmation. And now it has started collecting the memory dump image. Wait for this process to complete. The tool will begin capturing the entire contents of the RAM and save it in the raw file. So it's done. You can see that there is a file on the desktop names with the host name and raw extension which has the memory dump. When you will see its properties, you will see that it is 19.3 GB in size. This was all. How easy it is to capture the memory dump. The pros of DumpIt tool is that it is very fast and no complex options are there. It is perfect for emergencies. But a few cons are there that it has minimal customization. You can't select specific ranges or modules. But in most of our cases, DumpIt will suffice. It will do the job for us. Next up is FTK Imager, a bit more feature-rich and user-friendly for those who prefer graphical user interface. But before that, we are already into our malware analysis lab. We have live samples here also. In the previous video in dynamic analysis, you have seen how we have analyzed a core plug malware sample, which is a malware sample of plugx family. So let's first infect our VM with the same malware so that we can perform a memory dump analysis for that. Let's go to our malware repository, in which we will go to our dynamic analysis section, and here we can see our core plug file. Unzip it to extract the file. Enter the password infected. Again unzip it. Here you can see our malware file. If you have not followed our dynamic analysis video, I will request you to please go and see where we have analyzed this malware in very detail using process monitor, process hacker. Then we have mapped the same malware using a graphical interface tool named as proc.dot. Moreover, after that, we have also used sysmon to get sysmon logs, and we have finally displayed it on sysmon views. Please have a look on that video. For the sake of this video, I will go and first execute this malware. Now, after that, we will use FTK Imager to capture the memory dump of this VM. For that, go to our FTK Imager, which comes as pre-installed in our Flare VM setup. If you have not followed Flare VM, you can watch the first video of our series, which is setting up malware analysis lab step by step, where we have installed Flare VM on Windows VM using Remnix for getting network based artifacts. After that, we have also done static analysis of the malwares, in which we have captured strings, sections, packing, and other artifacts of a P executable file. After that, in our third video, we have also done dynamic analysis of a plugx based malware, which is a APT based malware, which contains 3 parts of files. Have a look on dynamic analysis video also. Since we have already executed our malware in the VM, it's time to capture the memory. FTK Imager is a multi-purpose tool. Here you can do image mounting. By image mounting, I mean you can mount and view pre-made images here. You can also create a disk image here. These sections will be covered in detail when we will do our forensics disk image analysis. For the sake of this video, we will just go and select this option in the file section, which is capture memory. Here it will ask for a destination path. Select desktop. Here it will ask for a file name. By default it is taken as mem.mem. Let it remain like this. There is another option checkbox for including page file sys. Page file sys is Windows swap space, which can also hold useful evidence. So we will select that also. There is another option of creating AD1 file. We will ignore that for now. Click on capture memory button and soon it will start capturing the memory. The main advantage of using FTK Imager is it is GUI based, which makes it very easy for beginners. It can capture pages and hibernation file, which can further help in our investigation. It has built-in hash generation feature also, which can be very useful in maintaining the sanctity of memory dump when it is being used for evidence purpose. There are some downsides also, like it is slightly slower than DumpIt. It takes a bit of more time and space than DumpIt, which is a easy to use command line tool. It has a larger footprint on RAM because obviously it is a graphical user interface based program, so it is more in size and it has a more footprint on RAM. So we will wait for the process to complete, and it is already 72%. It will take another minute to make our memory dump. It has already made the image. Now it is extracting the page sys file, which is of another 3 GB. Let's wait for this also to finish. Remember, in general analysis, we don't need page sys files. In our next analysis video, we are going to use only the .mem file to mount it on memprocfs tool and see what are the various kinds of artifacts which we can see here. I have only selected these options just to show you that there is an additional feature in FTK Imager tool where you can do such advanced artifacts collections also. I think this also will complete in next 20 to 30 seconds. Let's wait for it to finish. So our memory capture has done successfully. This is our memory dump file. You can see in the properties, it is also of 19.3 GB, which is equal to the size of the RAM allocated. There is an additional pagesys files also, which is a swap windows file. So now when we have made our RAM dump, we will go into our next process of analyzing it using another tool named as memprocfs. Memprocfs is a tool which has changed RAM dump analysis forever. Memprocfs was created by Ulf Friis, the same researcher behind PCI Leech project. It takes the forensic memory image like those captured with tools like DumpIt or FTK Imager and mounts it as a readable virtual disk. Imagine you have a raw or MEM file from a compromised system. Instead of parsing it manually using command line tools like volatility, memprocfs lets you mount the dump and navigate the process, DLLs, network connections, and even decrypted registry hives as if they were normal files. The magic behind this is the fuse, file system in user space concept. memprocfs uses tokeny driver on the Windows to create that virtual file system. Tokeny is essential, the Windows equivalent of Linux fuse. Without tokeny, memprocfs can't mount the memory image. So, in the installation process of memprocfs, we will go to the official GitHub page of memprocfs. Here you can see various details about memprocfs, that how convenient and easy is to view physical memory as files and virtual systems. You can also see the corresponding snapshots and the guidelines to get started. So while using memprocfs on Windows subsystem, there are basically two things which are required. First is tokeny and second is the memprocfs itself. So we will go here in the releases section and download the latest version of memprocfs. In the asset section, you can see an options memprocfs files binaries for Windows x64 system. We will download the file from here and save it on our desktop. After that, there is one another utility which is required for memprocfs, which is tokeny. We will go to the official GitHub page of tokeny, and again in the asset section, we will select Dokken x64 MSI installer file. Download this as well on the desktop. Since we have downloaded both the utilities, it is a time to install them. For that, go to the desktop and click on the Dokken MSI installer. Click open. You can see the Dokken installation wizard. Install it. Until the Dokken is being installed, we can unzip our memprocfs folder which we have downloaded from GitHub to see its contents. You can see here there are a number of files, utilities and dependencies which are there in the installation guide. You can see here we have successfully installed Dokken. Now time for memprocfs. But before that, we will need to take our memory image which we have taken for our malware out of our virtual box. For that, open the virtual box. Follow the same process by mounting our shared folder, but this time instead of giving something to the VM, for the first time we are taking something out for the VM. We have made a dedicated folder for memory forensic analysis. We will share it. We will go back to our VM, again open network share. In the network share part, now we will copy our memory dump so that it can be accessed from the base system. Remember, we will not be executing the actual malware in our base system. We are just analyzing the memory dump from it. It will contain various kinds of log files, registry artifacts, process handles, etc. So, the safety and security of our base system is in mind. Meanwhile, you can also do this same analysis on our VirtualBox system as well. But for speed and efficiency reasons, I am doing it on my base machine. Although I will recommend to do the analysis in the VM itself for foolproof safety. We will wait for the memory dump to get copied. Meanwhile, coming to the desktop, we have seen here that this was our folder where our memprocs file were located. Now we will open CMD as administrator. You can cd into this folder. You can see there is an executable file, memprocfs executable file in the folder. This is the executable file. We will execute it using the help command to see what all options are available in memprocfs. So, this is the semi documentation where there are various options like device to select the memory which you want to locate. Then there is an option for remote. You can see here in the example 4, there is an option to do memory dump analysis on the live system also by giving the shared memory path. Here there is option for verbose, page file, which we have already taken, sys file. We may also use this also in our analysis. Then there are various forensic modes depending upon the requirement which we want to have. We will dive into these one by one and see what all the options are available. Now it's time to load our memory dump in the memprocfs tool. For that, we will use the command syntax memprocfs.exe. We will use device to give the location of our memory dump which we have copied on a specialized folder in our desktop. Then we will use the argument here mentioned here, forensic 1. There is an additional feature of inbuilt YARA rules in memprocfs-SL. To enable that, we have to just pass this command, just copy and paste and press enter. What this command will do, it will check all the artifacts on the pre-saved YARA rules and show us if there are any matches. Click enter. Here you will see that on mount path M, it has loaded our image. It has also pre-detected our operating system Windows 10.190.41. If any one of you has used volatility before then, that you must remember what a pain was there to find the correct drivers for every operating system. But these things are automatically sorted by memprocfs. Now we will go into our Explorer, go to this PC, and here you will see a memprocfs folder which has been loaded up. By clicking it, you will see various kinds of options which are available. Remember, the processing and the log collection part is still happening at behind. It will soon get updated as soon as the tool is able to find out new artifacts for us. You can see here there are various folders like con, forensic, misc, name, PID, registry, sys, VM, etc. We will go in each folder one by one and see what kind of artifacts are there for us. And finally, we will try to hunt analysis about our Avast SVC malware, which we already run before collecting this memory dump in our VM. Now let us dive into these folders one by one. First, we will see the sys folder. In sys folder, there are various other folders. First folder is the certificate folder, which contains various kinds of certificates which are used by the Windows in various kinds of communications and transactions. You can see here these certificates provide security to various tools. There is a text file also which contains the list of certificates. For example, there is a GoDaddy certificate, then there is Microsoft RSA certificate, then the certificate for hotspot as well. You can find the list of all the certificates here. Apart from certificates, there is a list for various kinds of drivers which are loaded in the Windows operating system. There is a text file also which contains the list of all the drivers. Then there is a memory folder which contains details about various kinds of memory mappings. Then the net folder is one of the most important folder because it contains information about the ongoing connections in the RAM dump. It contains the dump of the net stat. You can see here the PID, protocol, state, source IP, destination IP, and various processes which are executing it. In destination IP, I'm not saying anything because we are using Remnix setup, because of which there is no external IP. There is a netstat verbose version also, which also contains the process path which is executing, which is making this connection. This also comes handy when we are trying to find out any current network connection which has been made by the malware in the memory dump. Many times during our incident response exercises, we are not able to identify or figure out any malicious file. But based on the information of the C2 or the process name, we are able to identify the C2 IP to which the malware is communicating or the path at which the malware is executed. You can also find C2 communications for memoryless malwares also. Mostly they use CMD or PowerShell to make command and control communications, which will be captured here in netstat verbose and netstat file. Then one another important folder is about processes. This proc text file contains list of all the processes which are running in the RAM dump. You can see here our Avast svc.exe is also running with a PID of 4408, and it was executed by John user on this and this time. These kinds of process details are also captured and written to a text file. Another file is proctime, which contains the information of process based on timeline. You can see here the time at which the process was started. Then is the process verbose. Like netstrat verbose, it contains additional information about the process, like command line, the path from which it was executed. If we will search our avast svc.exe, we can see here it was loaded from program data section on this time by this user for this PID. Various other kinds of process information can also be seen from here. Then coming to sysinfo folder. Sysinfo folder contains information about the VM. You can see here it has captured the computer name of the VM. It has also captured the operating system, which is Windows 10. It has also captured the time zone in which the VM is running, current time, boot time. It has also captured the RAM, which is of 19 GB, the CPU, which is 12 generation i7 processor, the user, which is John with its SID, active processes 133, inactive 4. It has also captured information about the network interfaces. Remember our first video where we set up our Remnix lab, where we have set up a DHCP server at 10.0.0.2 and our VM has been allocated an IP address of 10.0.0.3. It has also been captured here. Then this is the information about memprocfs and the current version which is it running. If we will come to user section, it will show you the current user which was running, which is John, and its SID. It has also information about the services. These text file also contains information about the architecture, computer name, time zone, etc., which we have already seen in system info folder. So sys folder is one of the most important folder and gives us information about the various artifacts which are there in the memory dump. Next folder which we are going to discuss in our memprocfs analysis is registry folder. Registry folder contains various kinds of subfolders like Hive files, Hive memory, HKLM, HQ, etc. You can see here that entire registry can be accessed from these files. In the HKLM sector subsection, you can see that there are various subfolders like hardware, security, software, system. We will click on the system and see control set 001, which is the current control set in use. You can see various hardware policies, services, etc. In control side, you can see various kinds of information. For example, if you want to see the current computer name, you can see here in the computer name there is a key and then there is a text file also. So memprocfs is very efficient in capturing the entire registry and getting all the values from it. It also makes the key file, and the same key file is denoted in the text document also, so that it can be easily accessed. There are various kinds of persistence which you can see and observe in these sections also. You can see here for John there are various kinds of in the HQ section. You feel free to explore these and see what all can you see from this. Next folder which we will consider here is PID. I have mentioned various times that every process running on the Windows subsystem is allocated a unique PID which is used to identify it. Similarly, there are various processes running on the Windows system which were captured by the RAM dump. During the analysis of our sys folder, there was a process file, which told us that our process is running with PID of 4408. Using it, we can see various kinds of other information from this as well. For example, if we will see this name file, we can see the name of the process. Then we can see the PID, time creation, the command line argument which is passed to this process. You can see that it is running from C program data part. Then coming up, you can see various kinds of modules which are loaded by the malware. Modules are basically the DLL files which the malware loads in runtime. And you can see there are various kinds of encryption DLLs and NTDL for network connections, etc. are loaded here by the malicious file. All this gives very critical information for us. But we know from our previous analysis during dynamic analysis that it was loading one another wsc.dll file, which was a malicious DLL file. Opening this, you can see various information about this. It will show you the base address from where the DLL has been loaded in the memory. It can show you the full name and the path of the DLL. Then it can tell you the imports. Remember lecture 2, static analysis, where we talked about various kinds of import functions which the malware makes for its functionality. You can see the list of all here, the functions and the module names. You can see various kinds of sections, text section, resource section, data section. All these things we have already discussed in our static analysis section. Then also there also I told you, knowing the structure of P executable file and how it operates comes very handy in our malware analysis process. You can see various kinds of details about dumps about these sections also. Then there is a directory. You can see import address translation table, security table, debug table, etc. and etc. All these files can be extracted and analyzed from it. Then one interesting feature of memprocfs is getting the mini dump of the process as well. If I want the dump of only this process, I can extract this from here from DMP file. There is various kinds of tool to extract and parse these dump files to get useful information. So these memprocfs is very efficient in extracting the information and showing it in a very simple way so that it can be analyzed and investigated. As there is a PID section, there is a name section also, where the processes can be seen from name also. You can see here that Avast SVC process and other processes can be opened like that also. It will show the same information as the PID section. Only thing is that here they are named via name so that they are able to identify easily when the PID of the process is not known. Now coming to one another important folder is forensic folder. Forensic folder contains various kind of subfolders like CSV file, NTFS, etc. I will explain them one by one. If you will open CSV folder, you will see various kinds of CSVs containing very important logs like timeline NTFS logs. NTFS logs are basically all the logs for NTFS system of the Windows where processes or files are created or dropped. It contains a timeline for processes also. Then timeline for registry. This can be easily accessed and seen. memprocfs not only gathers the information, but it parses the information as well, because of which the analysis becomes very easy. There is a search option also which is available in this app, Timeline Explorer app, using which various processes can be searched as well. Again, there is various kinds of information like prefetch files. There is a CSV file for timeline of all, which contains everything, every log in one file. If you want to have a comprehensive analysis of all the events that are occurring which are captured in a memory dump, you can open this timeline all app, which will contain all the logs in one go. Hence, it makes correlations and viewing the timeline easier as well. As the file is big, it will take a bit of time. The app I am opening here is Timeline Explorer. I have already shown you this app in my earlier videos. It is a sort of an advanced sort of Excel which makes analysis, searching, sorting very easy. I highly recommend you to use Timeline Explorer for your daily task. So here it is open. You can see here that all the network logs, registry logs, NTFL logs are there, and you can see in the time that they are sorted based on a time, so that you can see what actually happened on the system and you can correlate your events. Now, apart from CSV, there is a separate folder for NTFS also, timeline also, for web also, which contains the information about all the web requests which are made, which were there in the RAM dump. You can see that attempts were made to Microsoft, Google, etc. and etc. One another important folder in this is find evil. Remember when we were running our memprocfs, we enabled our Yara rules also. Now, this feature scans the entire memory dump and gives us the matches based on the matched signature which were there in its repo. If you will open findable, you can see various kinds of matches which were made. We can clearly see that our malicious process avast svc.exe has been flagged as a Trojan and used as a Windows Trojan Cobalt Strike family. Various other kinds of anomalies are there. This becomes very handy if you don't know the actual malware which is there. In this case, we already knew that there is a avast.svc.exe named malware which was running. But even if you don't know and you have no clue about the malware, running this process can give you insights to start upon your investigation, which comes very handy. You can see here in this which kind of Yara rules were triggered. Here, Yara rule for Cobalt Strike was triggered. You can see the threat name, reference sample, and all the other details. You can see here the last time where it was seen. You can see this string which were matched based on which these were flagged. This is for other Trojans which were there. You can see here that our avast.exe which is loaded from program data is flagged. So this is a very handy tool which helps us in investigating the cases. So this was all from the forensic section. Please feel free to explore more, and if you find something new, write in the comment section also. So memprocfs is an incredibly powerful for quick interactive memory analysis. Unlike volatility, which requires you to run commands and wait for the output, memprocfs lets you browse memory like a file explorer, perfect for incident responders and malware analysts who need speed. But remember, always work on the copy of memory dump, never use the original. Always use the forensic mode 1 so to avoid any accidental modifications. I have tried to give you a beginner's guide to memprocfs. There are various incredible things you can do with this tool, but my idea was to show you various kinds of features which are available so that you can use them and explore them in your learning process. That's it for today's tutorial. I hope the entire process where first we collected the memory dump using DumpIt and FTK Imager, then the analysis done during memprocfs was helpful for you. If you like it, hit the like button, subscribe to the channel, and let me know in the comments if you want a live malware analysis session with memprocfs. Thank you for watching and stay safe out there.